Okay, points A, B, and C are three vertices of a parallelogram. So I'm probably going to start by graphing these 3 points. So I've got a -3, -1, a -1, +1, and a 1, +1. Your goal right now is to figure out how many parallelograms could be formed using these 3 points. So what that means is I need to find the 4th point, or the 4th vertice. So I guess by looking at it, I would try to figure out where the parallelogram is being drawn. And I guess the most obvious one for me is to view this is the top, this is the left-hand side. And then I would replicate that left-hand side here and then continue to be the bottom. So my first answer here would be -1, -1. For me, that's kind of the most obvious one. But there are more. Instead of picturing this as being kind of the bottom left, and this as being the top left, and this as being the top right, what if instead this point on the bottom left was actually the bottom right of the parallelogram, meaning that the other side was actually here? That would also make a parallelogram. So there's a second parallelogram that can be made given the original points and the point -1, 2, 3, 4, 5, -5, comma, -1. The third one is a little harder for me to see, so I'm actually going to erase and start over. The third one would start again with -3, -1, -1, +1, and 1, 1. But the 4th point would actually be viewing, oh gosh, let me see if I can figure this out. This as, what would it be, 3, 3? Oh, okay. So it would be viewing this as the right-hand side, but viewing this line as the bottom. And so that would put the top point, I think, there. Let me check. So if that were the right-hand side and that were the top, let me make sure that I rise to, run to for the left-hand side, and I rise to, run to for the right-hand side. Yeah, that works. So that point is 1, 2, 3, 3. So there are actually 3 possible parallelograms, depending on which location you consider each of those points. So the answer to A would be 3 parallelograms, and the answer to B would be the locations of those 3.